push ahead with the second speaker, who just arrived just perfectly on time. Charles Cranstoun is going to talk about a new paradigm of lunar communication and navigation.
Hello.
Take it away.
Fantastic. Let me share my screen. Excellent. So today I'm going to talk about the work that we're doing at SSTL under the SSTL Lunar brand, which is going to cover Lunar Pathfinder and the ESA Moonlight initiative that we are working on. So with Lunar Pathfinder, we'll cover the what, why and when, and the latest updates on the project. And on the ESA Moonlight initiative, we'll cover the progress on the study and the aims of what we're trying to achieve. So yes, it is official. SSTL Lunar will connect from the moon. We have an anchor customer with ESA and are deep into the detailed design phase of the Lunar Pathfinder mission, and in parallel working on the study with ESA as part of the consortium we're leading for the Moonlight initiative. Here we have the Lunar Pathfinder satellite as it is at the moment, and launching with the target date at the back end of 2024, we'll be able to provide commercial relay comms. So big question is why the need for lunar comms and nav services? Well, over the last number of years, we've been developing a market analysis and business case around the need for data services around the moon. As you can see, over the next couple of years, the number of active missions around the moon will be increasing. This stage is a little bit out of date, so it has slipped to the right somewhat, but we're fully anticipating a significant uptick in the number of missions, and hopefully that's been reflected by some of the conversations that you've been having over the last few days. As part of this, naturally, you expect the number of megabytes we want to get back from the moon to significantly increase. And this is what we have been modelling as well. So by providing these comm services, we can be a key enabler for some of these missions and hopefully accelerate some of the great work and science missions that are planned to take place. The other bonus of our approach is that by focusing the backhaul capacity through ourselves rather than individual missions, we can reduce the strain on the direct-to-Earth comms networks and therefore provide a single point of contact to getting the data back and supporting those individual missions. So Lunar Pathfinder, we've been developing this over the last 6 years with close collaboration with ESA and more recently with NASA, understanding their needs, and we are well into the detailed design phase at this stage, starting to manufacture hardware, looking for a launch at the back end of 2024. Next year we start moving into our AIT and EVT phase, while in parallel doing a large number of flat-sat testing to de-risk moving forwards. Pathfinder will provide data relay for all lunar missions, both far side, polar, near side and orbital, and any types of surface, static and orbiting. That includes rovers, landers and any other missions. A key enabler for exploration and science as it solves the line of sight problem, especially for rovers. Missions. So in the rover case, rovers that are dropped deposited on the surface will typically rely on either direct-to-Earth comms, which are very power intensive and may limit the mission, or more likely they will use more local signals back to the lander, which will then handle those comms. Unfortunately, with the lunar night being so cold and harsh, the probability of surviving in the next couple of years is unlikely on the lander side, maybe more likely on the rover side. But this does mean that if the lander dies, the rover has no way to communicate back. Similarly, if the rover moves out of line of sight of the lander, suddenly there's no link for the comms. By having Lunar Pathfinder in orbit, though, we can provide that comms link directly back. It also enables users to take a lighter and cheaper user terminal for a better data rate to the moon, reducing their comms burden and allowing more focus to be placed on the actual science and purpose of the mission. So Lunar Pathfinder itself, the communication to the Earth is done via X-band Earthlink, and then on the moon side we have S-band and UHF. Very much on the UHF side, that is something that we are aware of the sensitivities on the far side, and we'll be planning our missions accordingly For example, some missions may require ultra quiet on the far side, and UHF can be noisy in the frequencies they're looking, so we would be coordinating on that front. Number of hosted payloads, so we're taking a laser retroreflector, a GNSS weak signal detection, and a radiation monitor. The radiation monitor will prove invaluable in gathering more data about the radiation environment, allowing us to better design craft and missions in the future by understanding what environment they will be subjected to. The GNSS weak signal detection and the laser retroreflector are key experiments that are ESA and NASA led. The signal detection will be used in conjunction with the laser retroreflector and our own ranging to provide unprecedented amounts of data in understanding the accuracy and what is achievable for navigation in lunar orbit. By doing this, we lay the foundation and a pathway for the Moonlight capability for their GNSS and navigation capabilities. So we have a number of external activities been going on our website. You can access a Lunar Pathfinder mission builder app, which allows you to put the high-level mission characteristics, such as location, mission dates, frequency band used, and a number of other pieces of data, and then receive forecasted coverage and performance reports. It's meant to act as a gateway for further discussion, so if you are interested, please do get in touch through the links on the website. We've also published our server guide, or in the process of publishing our server guide, I should say, and it'll provide details of Pathfinder, its suite of communication services available to customers, describing what they need to do to be able to interact with us. We've also secured ESA as our anchor customer, and they will be procuring comms services from Pathfinder to enable their future lunar missions. We are, of course, a commercial relay, so ESA, while being our anchor customer, we are pursuing other commercial opportunities with other organisations. So if you do have missions that you'd like to be serviced by, please do get in touch. As mentioned, in parallel, we're working on the ESA Moonlight initiative, and in quarter 2 of 2021, ESA selected 2 consortia for the parallel phase A/B1 studies in this initiative, built off the back of the Lunar Comms and Nav study that they did a few years ago. The purpose of this is to investigate the potential for a full lunar constellation that provide enhanced comms and navigation service. So really trying to lay the foundations for supporting these long-term missions that can survive the lunar night for significant amounts of data gathering and support. The study is defined both the technical and commercial feasibility of the infrastructure and describing the full end-to-end system. So that's the space segment, the surface segment, and any other user and ground segments involved as well. We're building upon our expertise of Lunar Pathfinder for this, leading this consortium across Airbus, GMV, KSAT, Goonhilly, SES, and of course ourselves leading. Benefits of the comms and nav system, be it Pathfinder or Moonlight, we've talked about solving the line of sight problem. It does help us reduce costs for lunar missions by having optimized ground segment costs, reducing the range for the need for ranging and navigation and backhaul of the aggregated comms data. It's simpler, lighter and cheaper comms through this user terminal and the navigation of onboard equipment versus those that are required for direct-to-Earth. And of course, direct-to-Earth is not achievable on far-side missions and maybe even in some polar missions. So Pathfinder can offer, and Moonlight can offer this capability. Worth noting that Pathfinder has an electrical frozen orbit that will linger over the South Pole, as that is where we see most of the significant missions and interesting sites taking place over the next decade or so. Increased performance as well by using our missions, the better data rate for the comms versus achievable through direct-to-Earth or the local Wi-Fi from landers, a more precise navigation accuracy, and more data for the same terminal, which can be translated into greater scientific output. We are heavily focused on interoperability as well, so looking to integrate into the lunar ecosystem with NASA LunarNet and the Lunar Gateway, and we can easily leverage the capabilities for use on institutional, commercial and government users alike. And on availability, as we mentioned earlier, the DSN is routinely oversubscribed, so we're offering a separate, different route to utilise these and increase the overall global capacity for lunar comms. And the Moonlight constellation will provide enhanced coverage anywhere on or around the moon, rather than just lingering on the South Pole. And while Pathfinder can access the North Pole, the contact times are far less, but our market analysis has shown it's on the South Pole where the interest lies. So from a conclusions point of view, we are at the start of a new lunar renaissance, and we are here to facilitate that growth and putting that infrastructure in place to allow everyone to access and make the environment at a cheaper and more less risk intensive approach. The Pathfinder Moonlight Comms system will help catalyse this growth, enabling disruptive applications and business models to be put in place. So please do contact us if you have any information. It's lunar@sstl.co.uk and visit our website for details of that mission builder. We are more than happy to listen and discuss your capabilities and how we can support you in achieving your mission goals. Thank you.
Perfect. Thank you very much. If there are any questions, please put them in the chat. I don't see any yet. Oh, Mahesh, go ahead.
Yeah, I can talk quicker than I can type. Sorry. It's just a fascinating talk. Last slide that you showed was really interesting. I mean, are you imagining a constellation of Pathfinder type satellites all around the moon in future?
Yes, so apologies, that probably didn't come out, but for Moonlight it is a constellation of satellites. A minimum of 4 will be in orbit to give global coverage at any point around the moon. Great.
And how long is the anticipated lifetime? Like, you know, when do you need to service it or just send another one to replace it?
So Pathfinder has an 8.5-year lifetime. The half is to cover the commissioning period, but 8.5 years, and SSTL missions have routinely lasted longer than that, longer than their lifetime. But we will be overlapping with the Moonlight initiative as well. So Pathfinder will be, exactly as it says, a Pathfinder, and then the Moonlight constellation will provide that global coverage. That may be done in stages rather than one launch altogether, but it will help to build up that capability as we progress.
Thanks.
No problem.
We do have a question in the chat for you, Charles. What system is necessary on a rover to get a positioning signal?
Good question. I'm not sure of the answer to that. Our user terminal that we will be developing will likely have the capability to provide that positioning based on the information that we have in orbit. If you want to get in touch, I'm more than happy to pass that question to the relevant team who can provide you an answer on that.
Perfect. And I think we have time for one last question. Simone, if you want, you can just speak up.
Yes, I just want to make a comment. The Moonlight initiative that is at the core of this Lunar Pathfinder is also called by ESA LCNS, which is the acronym that I used before, Lunar Communication Service. We were talking about the same thing, of course, from two very different perspectives. So Moonlight and LCNS are the two names that ESA uses.
Yes, that's right. Yeah, so we worked on the LCNS study early on when it started, and then we've set up and leading the consortia for what is known as Moonlight now. But yes, one and the same.